Welcome everybody to the Cobalt Strike 412 release party. Um, it's for some of you quite early in the morning, for others it's late in the afternoon. Let's give each other a minute before we start with the content. Welcome everybody. Let me see the numbers of you see people dropping in. So welcome all. Um, So we have quite an action-packed agenda as we have a release party today, something to celebrate. So again, welcome all. My name is Peter. I am the product owner of Cobalt Strike, and today I am presenting here together with various of my colleagues. We have Will, our research lead. We have Chris, one of the software developers. We have Pablo, the product manager, and Steve, an offensive researcher. And today we'll talk you through Cobalt Strike 412 and what will be included in it. We're doing this via GoTo, meaning you can ask questions whatever you want. We will try to keep an eye out for any questions you raise, and can either answer them directly to you one-on-one, and if we deem them those are relevant for everybody, then I will either rebroadcast them towards the speaker, or we'll put them in a chat so that everybody can see it. So your questions are one-on-one to us. Feel free to drop any questions or feedback on the product that you have. With that being said, let's have some fun and let's see what we've been cooking the last half year. So what we'll do in the upcoming hour is I'll first give you a short intro on overall Cobalt Strike and where the release is working on, and then will dive into user-defined command and control (UDC2). Steve will talk about process injects, UAC bypasses. Myself and Chris will talk about REST automation and server side. And Pablo will demonstrate that given this REST automation, what you can actually do with it. And he'll demonstrate some very cool prototypes. So about Cobalt Strike, for those of you that are new to the product, Cobalt Strike is a threat emulation framework. It's a C2 framework, and it is by its foundation designed to mimic anything. So it's highly configurable, meaning you can do pretty advanced things yourself with simple configurations. But it's also very much customizable. If you don't like our presets or our options, you can do it yourself. We have a lot of evasive options, so some things are in its default states fairly trivial to detect, but with this customization, you can make it look like any real malware out there, almost unlimited possibilities. You can change it in any way, and there are a lot of options. We have scripting as a key part of the Cobalt Strike user experience. Aggressive scripts, a huge amount of public and open source CNA scripts. And in Cobalt Strike, we really believe in this openness and togetherness. It's so extendable, countless community projects that help us, and your feedback also helps us improving our product. So when seeing Cobalt Strike, don't only see this as a C2 framework or as a red teaming framework, but also as a tool for evasive research, a tool for offensive research. We want to I have options for both the red teamer, but also as a research vehicle. With that being said, let's assume that most people know a bit about Cobalt Strike. If you're coming to a release party, and let's discuss what we're changing in this release. So in a typical setup, we have a couple of components at play. So this would be on the left-hand side, the attacker infrastructure, and on the right-hand side, the victim network. On the attacker infrastructure, we have the Cobalt Strike team server controlled via a Cobalt Strike client. The team server has maybe some internal network or some tunnels to relay servers or redirectors. And then on the victim network, we have our well-known beacon. That's the implant that makes communication probably via HTTP, HTTPS, or DNS, back into these redirectors and into the team server. And via this mechanism, you're capable to control Beacon from your client via the team server. So this is a schematic that maybe it has been a bit polished, but for quite some of you has been a well-known concept. And we're not about to change it dramatically yet, but there are some major architectural changes ahead. So the first change that we're doing, I'm clicking on the wrong screen, is we modernize the GUI, and I'll show you a preview in a second. That's just a small thing, but a new client, new themes. We introduced a new mechanism for communication. So an alternative to external C2, we now have user-defined C2. Within the beacon, we improved various things. Today we'll talk about process injection and UAC bypasses, but at the last slide we'll show what else has been changed in the beacons field. And then we're also having a major architectural change with server-side storage and REST, which is a bigger journey ahead of us, but we're also already releasing this one in beta. In summary, if you look back at the highlights that I made on those slides, we're actually changing a lot in all areas of the product. And this has its impact on the release pace. So we set out this meeting and scheduled it like a month ago. We thought, well, by this day we should have it done. Of course, sometimes bugs emerge, and our rigorous QA process needed to go through. So we really believe that today we squashed the last bugs, we merged in the last codes, and we hope to have it in your hands prior to Thanksgiving. So that's kind of the overall status and of the 4.12 release. It's the final RC is hopefully soon in our hands, and then the final release in your hands very soon afterwards. As mentioned in the introduction, one of the things that we're changing is we modernized the GUI and we introduced themes. This is not the only time you'll see new GUIs for Cobalt Strike, but that's for later for Pablo. We're introducing this new theming. We still have a legacy color scheme. Or an old school color scheme as I'm used to personally, but a lot more options there. And this also allowed us to deprecate some libraries that we want to get rid of. So this was part of an engineering effort to modernize the client and also give you a nice way to customize the look and feel of Cobalt Strike. Quite some cool themes. Each of us have their own individual preference. We have a couple of demos and recordings later down the line. You'll see some of them in those. And with that being said, GUI's themes is a not so technical subject. Let's move over to Will for a more technical subject. So Will, can you talk us through user-defined command and control?
Hello, yes, hope I can. Hello everyone. Yeah, so I'm William Burgess. I'm the principal research lead of CS. So I help decide on the sort of technical roadmap of the product. So if we go to the next slide. So historically, and to date the product now, so the HTTP and HTTPS/DNS beacons are like the sort of classic workhorses of CS's C2 capabilities. And I think with malleable C2, that idea of being able to tweak the content, to merge in and stuff was incredibly powerful, and broke a lot of like network monitoring style stuff, because with that ability, it was very hard to do that static signatures, etc. I think where those sort of main use cases fell, Raphael introduced external C2, And this was for more, I think in Raphael's language, esoteric, or those strange use cases where those things weren't sufficient and you wanted to do something different. And it was like a software contract or a programming contract. It allowed you to write these custom clients and do very interesting things with Cobalt Strike. And I actually remember I was a consultant at a smallish UK consultancy when External C2 came out. And I remember the day, and I had great fun playing. I think I proxied it over Gmail, which was one of the first POCs which came into C3, which I've got on the slides there. And so External C2 was hugely powerful, but I think it had some limitations which I think made it hard to use operationally. And this was broadly because the general dynamic is at least initially, you got a payload, you inject it into memory, and then you had to, it was basically an SMB beacon, so you had to connect over name pipe and then relay frames. What this meant is that you had the dependency of another client, which you had to handle in your loader, and it was sort of coupled to that. And it was not insurmountable, but it made it sort of slightly a bit unwieldy, I think. And so in Cobalt Strike 4.12, as Peter said, we've introduced UDC2 to address these limitations. And so the TLDR of UDC2 is you can write custom C2 channels as BOFs. And these kind of operate similar to the sleep mask, is that you can create a listener, give it this BOF, and it will just patch that into your beacon payload. And then once beacon executes, it will just automatically use this BOF, and then you can proxy it over whatever. So it gives more of a native feel. It cuts out the name pipe. And also it means that you can use UDC2 with existing transformations, with URLs, which comes real power then. So you can just completely decouple it from these other components. And so what happens is whenever beacon has some traffic it wants to send, it will invoke this BOF. Your BOF will send it over the custom channel, and then kind of similar to External C2, you'll have this UDC2 server or the relay, which is basically going to take out beacon's encrypted frame data and just give it to the UDC2 listener. And in that way, you can kind of go ham creating these custom things. So we have a quick demo to show you of it in action. So as part of this, we're open sourcing an ICMP egress channel. So this will be a lot of the team use Visual Studio. So this will be a Visual Studio template, although you can obviously use whatever you're kind of familiar with. So in this demo, I'm going to build this ICMP egress BOF. As a note, if you do play around with this, you'll have to change the actual IP that your UDC2 relay is going to be running on. So I've built it in release there, and then I'm going to go through the process of setting up a UDC2 listener. So if I open the client, I'm going to say add listener, and I'm going to check user-defined C2. Currently, this is only limited to one arch, so make sure it's helpful to say x64 so you remember. And then likewise, I'm going to choose that release BOF. Now the listener started, I'm going to start the relay. As a note, I'm using WSL for testing purposes, so I'm pinging to WSL and then relaying it. As a note, for the ICMP one, you'll have to disable echo requests, which is just demonstrating that there. And I'm going to start this UDC2 server. Now we can see that's up and running, listening for requests. And then we can start Wireshark just to verify, and this is on the WSL interface just to see the traffic later on. So if I now export a payload, I can choose my ICMP listener and I can generate. And this is, again, it's going to patch that BOF into my payload, and then Beacon's going to run it. So we execute that, we get a shell. And then if we inspect our relay, we can say it's got a new beacon connection. It's giving it like a custom ID, and we can see it starting to exchange data over an ICMP egress channel. Likewise, we can confirm in Wireshark, we can see the traffic going on. And to sort of demonstrate the more native feel, I'm going to give a little process listening here, and then I'm going to inject into another process. Peter, the demo may have paused briefly. Okay, it's back on now. So now I'm going to choose just a notepad process. This is a little teaser of what's coming up. I'm going to choose the method. and then I can inject in that, and I can choose again my ICMP beacon. So this obviously is over ping, so it's going to take a little bit of time, but we will get a shell shortly. And then likewise, we can check the server again, and we can see it's got a new custom ID, so a new beacon's connected to it, and now it's relaying it for both of them. And so that's a really quick example of hopefully the power of UDC2 in action. And then with that, I will hand it over to Steve, who's going to talk about new process injection and UAC bypass options.
Yep, thank you. Yeah, awesome. I think you may have skipped a slide, Peter. But hi, everyone. I'm Steve. I'm a researcher on the CS team. I get to work with Will and Chris Thorpe and really everybody to work on everybody's favorite command and control framework. And so today we're going to talk about some of the changes we made in 4.12. Peter, if you can go to the next slide.
I think you want this one. I'm not sure what's going on with my deck, but you want first one, this one, right?
Correct. Yes. So the process injection changes we made as we're all probably familiar with, process injection is a mechanism of achieving code execution in a specified process. And in the Cobalt Strike framework, we have two really contexts in which that's applicable. The first context is the explicit injection, where you provide a process ID, and that'll inject your code, whatever that payload may be, into that specified process. We also have work and run injections, which spawn a new temporary process, and that's where your payload will execute into. And in Cobalt Strike 4.11 and earlier, custom implementations were available to customers via the process inject kit. So if you didn't like our injections, you wanted to do something very complicated, you could implement that as a BOF, and then you would use that through the process inject hooks for various capabilities in the Cobalt Strike framework. We also had a select set of injections that were implemented directly in Beacon. We continue to have those, continue wanting to support those. And there's customizations for those as well inside the process inject block for some flexibility. Now, a small limitation of that is that changing an injection means you have to rebuild your beacons. Additionally, from a development point of view, adding a new injection means you have to increase beacon or increase the size of beacon. And so there's a couple of things there. And so in Cobalt Strike 4.12, we pushed the boundaries a little bit by implementing some new injections as beacon object files from the Java side of the process inject hook. And so what this allows us to do is you now have this hot swappable menu where you can change your injection technique depending on whatever context it is you want to use that technique in. And you can also add your own injection BOFs to that UI element. And if you go to I think now the previous slide, Peter, we'll take a look at that. All right, so here we have our Cobalt Strike client, and you'll notice in the top here, we have this new advanced config menu, and we can click on that to see this new process injection dialog. Inside of this dialog, there's really two dropdowns. There's the explicit injection dropdown, and again, that's going to be for injection techniques or for contexts where you can provide a target process ID. And we have some pre-implemented beacon object files that are available from this dropdown. So I'm just going to select the clone user process technique. The second dropdown that we have is the fork and run dropdown. And that's going to, again, be in context where we're going to spawn this new temporary process. And that process is what's going to run our payload. And so here in a moment, I'll select the early cascade technique. And then we can just apply those to our client. Now, to access these selections, we just have to use a command that's compatible with the process inject hook the same way you would in previous versions of Cobalt Strike. And so we can do something like power pick, get service, and we'll see here that the video may have frozen. There we go. Power pick get service, and we'll see here that we'll get our injection technique is used. We get that confirmation message, and we see that we do get the list of services running on the victim machine, right? So we see here we did use the early cascade injection. And so now if we want to use the selection we made for the explicit context, we can use something like the inject command. And so we'll first find a target process. We can do that with PS. So here I'm going to select the explorer.exe process. And now we'll just inject into our explorer.exe process. We'll specify our listener name. And when we execute this command, we'll again see our injection technique was used, and we'll receive a new injection, or excuse me, a new beacon session in our sessions list. And now there's one more thing we can do here. So you can see here, I don't have any CNA scripts loaded, and we'll actually go to this CNA here, process inject.cna. You'll see we have these two new hooks that have been added to the framework, process inject explicit user and spawn user. And what these hooks allow you to do is to specify an injection name and a path to your injection BOF. And you can return that into your client via this hook. And the client is aware of these hooks and is able to take the information you provided and actually add it to the dropdown we saw earlier. So if we load that CNA, go to advanced config, we can actually see that my favorite explicit injection was added and my favorite spawn injection was added. So we can apply those now, and we'll actually be able to use them from our beacon session in the same way we did earlier. And so I'm actually going to run the exact same command. So we'll see power pick get service, and we see now that we did use my favorite spawn injection. We'll scroll up here and take a look at that. And similarly, we can inject into explorer.exe again. And we'll see that we did use my favorite explicit injection, and we did receive another beacon session from explorer.exe. So there you have it. You now have the power to use our new injection techniques, as well as to seamlessly integrate your own injection BOFs. Peter, can I get the next slide? Now, the other component that I'm going to talk about today is the new UAC bypasses that are part of our release. And so if you're not familiar, if you're not super familiar with user account control, it was introduced in Windows Vista around 2007. And really, it's a way to manage privilege elevation. It allows system administrators to separate user activities, standard user activities, from administrative tasks. And so you'll bump into this for some post-exploitation tasks for accessing the memory of a specific process. And so in Cobalt Strike 4.11 and earlier, custom implementations of your own elevation techniques were possible through the Elevate kit. And the built-in support was really targeted for older Windows versions. And so in Cobalt Strike 4.12, we refreshed that support, and we added these two new UAC bypasses, UAC RPC DOM and UAC CM Lua. And they're based on existing research with a little bit of fine tuning for our specific use cases. And UAC RPC DOM is available in 2 commands, elevate and run as admin. UAC CM Lua is only available in the run as admin context. Slide, please. So here we'll take a look at how we can use these techniques. So here again, we have our Cobalt Strike client, and the UAC bypasses are available in those 2 contexts, the run as admin and the elevate command. And so if you want to see a list of the available UAC bypasses for a specific command, you can just run that command from the console. So here, if we run as admin, we see that both of those UAC bypasses are available to us. You also see that the supported Windows versions, the versions we've rigorously tested, are annotated in the command line. This is another small tweak to a quality of life change we made for 412. Now, if you run the elevate command, similarly, you see the 2 available techniques, and the relevant one for our conversation today is UAC RPC DOM. And so we'll actually go ahead and use that. We're going to elevate UAC RPC DOM, and we'll specify our listener. And we'll see here in a moment that we'll receive our new beacon session from our spawn2 process. I was using the default malleable configuration here, so it'll be run DLL32, and we see that session there at the bottom. Now, if we wanted to use the other UAC bypass, we can do run as admin, right? We can again see that list. It's available to us in the beacon console. We can do run as admin, and we'll use UAC CM Lua this time. And for demonstration purposes, I'm going to do something a little bit silly here. I'm going to start an elevated char map process. That's just so that we can see this on the victim machine. So we see here, when we run the command, we get a success message. And if we go to the victim machine, we'll see here that we do have an elevated char map process that was initiated by our elevated command.exe process. And so with that, you now have these refreshed UAC bypasses that give you access to some elevation. And now I think I'm passing it over to Pablo. So I'll hand it off to him.
You're handing it over to me, Steve. Yes, so I'll take a couple of minutes to talk about REST. So as mentioned in the introduction, we have different user bases. On the one hand, operational red teamers, people that want to do offensive research. And we set out a couple of longer term objectives that are maybe not so much in Will's turf of like the technical and the beacon part, but more how do you want to operate your team server on the longer run. And as a red team manager myself, I had my own saying in this as well. So I rather have a central location for managing configurations and artifacts. Cobalt Strike historically relied for quite some things on the client. But as a red team manager, I want all my team members to use the same Rubyous version or the same BOF. So that was one of the things that we're setting out to do. The other thing, and that's also a much demanded thing from our customer base, is to introduce alternatives to aggressor scripting. So on the one hand, why can't I talk Python to Cobalt Strike? With the upcoming of LLMs, should this integrate with Cobalt Strike? But on the other hand, we want to retain CNA scripts to function because we have a large repository. All of us have a large repository of them. And the third longer-term objective that we have is to introduce capabilities like roles or command restrictions. I mean, having a junior operator in your team, or maybe the future is there and we have AI bots automating our Cobalt strike. Well, maybe I want to restrict him from doing too dumb or naive things. And those three items are what we're working on. They're not all included in this release. So in this release, what we're doing is we're introducing the beta for the alternative to aggressor scripting. So you can, as demonstrated in a couple of minutes, talk any programming language, integrate LLMs, also retain your CNA. We're also laying the groundwork for the central location for artifact management. And as you see how we architected the REST API, this will for us also on the longer term introduce roles or capability restrictions as well. But when we started this journey, it was quite a step away. So it was quite a we had to look up where we were like in the previous release in terms of architecture of the product. So Cobalt Strike started like 15 years ago, like long time ago, and the architecture is the team server more or less acts as a broadcaster for messages. It just broadcasts this to all the fat clients. And I personally, for me, this resonates with something like IRC. So you have a relatively thin and simple team server and quite some logic on the client side. And there are huge benefits from this. So all the client-side scripting, the development, and like the tinkering, tailoring Cobalt Strike, the sleep CNA in your client, that's really handy to have it at hand. But there's also a drawback. If you have a really thin team server with limited central logic and capabilities, how can we hook this one up into this modern world of LLMs? How can you talk to this with other programming languages? So what we have done in the past period is we've built a new REST service, which is a separate binary that runs alongside the team server component. So it's a separate binary that should run on the same server, and that binary just talks to the team server as if it's a client. And it exposes all the Cobalt Strike functionality, or like 95% of the Cobalt Strike functionality towards users via REST. And that is the bridge for any LLM or Python or Rust to work on and to program against. That was change one. So a change where we're introducing a new service executable. In this release, we're introducing it as a beta because this is an architectural overhaul as part of a longer story. We really need the users' feedback and get some traction and feedback from all of you. Another thing that we had to do was if I, from another programming language, issue a command, I want to get the results of that command. And historically, that was quite hard in Cobalt Strike to do that properly. So we also made changes in the team server as well, where we now have task and state tracking in the team server. So the team server maintains information like this command was issued, this is the response to that command. And with that being said, I'll do a very short introduction to getting started with REST, and then I'll hand it soon over to Chris. So getting started with REST. So on the left pane, we start up the team server with the normal parameters, but now we add one parameter saying, I want to start up this team server with the experimental database. For now, as it's beta, we call it the experimental DB flag. This means that the state tracking is done in the database. And then the team server just starts up as normal. And then on the same host, you would run the CS REST API service, where you provide the password to log in on the team server. And this will start up port 50443. where there will be a Swagger interface. And here you can first authenticate. You can authenticate at this point in time with the password that you also use to start up the team server. So just like that's the password. As part of the bigger journey, we're likely changing that if we want to introduce roles and capabilities. So here we're authenticating. We're getting an access token back. And what we can do in the Swagger UI is we can copy that and put it so that it will remember everything for us in the later requests. So now we're authenticated to the team server, and we can, for example, you see a nice structure. This is all about beacon info. So let's try that. We execute the one that returns the metadata of all the existing beacons. And here we see the beacon IDs, the hosts, the processes. We get all the metadata out of it. And later on, if we want to issue a command, we can get like the beacon IDs from this listing to issue the command on a specific beacon. So the examples here are in a web UI with Swagger, but as you see, there's also like curl examples, and you can use any programming language. In architecting the REST API, we also had to make some decisions about like how and like what endpoints are there, which routes are there in REST, and we introduced two ways on accessing or executing commands. On the one hand, on the left hand, we have a console command, and you can see this more or less as I can just literally type in what I used to be typing in the console. So of course, it's JSON, so you may need to escape a slightly bit different, but on the left you see command is lsc/users, and you just throw it over the line, and it's a console command, and that's kind of it. And on the other hand, we also reviewed all our commands. We put them in a structure, and that's what you see on the right-hand side. So we have a grouping of all REST APIs that have something to do with files and registry. And we have something like on the bottom right, execute/ls, where execute means it's only win API, so it's not spawning, not injecting, and it's executing ls. So if you play around with the Swagger file, once you started up the team server or the REST server, you'll directly get a bit of feeling about how these things are grouped. And in general, I think I would recommend using the structured commands because they give you much more insight about what's going on, and also you can do things like instead I run ls and I provide a path as a variable instead of like a string where maybe the second parameter has a meaning in the console commands way of working. Of course, commands also get responses. So how do we collect those? And for that, I'll pass it over to Chris.
All right, hi, I'm Chris Thorpe. I guess I've been on the Cobalt Strike product now for a few years now, and one of the software developers. So we'll jump into the next slide, I think, Peter. And so we're going to go through and kind of do a little bit more of this task management stuff here. Obviously, we're going to log into the Swagger UI. Usually, a lot of times, you're going to need a beacon ID to run commands on. So we'll just copy one there. And we're going to go down to the console command, I believe. And we're going to go ahead and click on the try it out and paste in our beacon ID. And then down here in the body there, we'll just put a empty string in there, which is basically the current path. Or you can supply the path from like the previous example that we had. This will respond with a small little snippet of JSON. Usually what we're grabbing here is the task ID. Copy that. We'll go up to the task endpoint. And we will try that out, pass in the task ID there, and then we'll execute that, and we'll get a response back. And response will have all the information of the ls command, and you can see that it's in a structured format, so you can kind of see the name and file and sizes and stuff like that, as well as other output information as well. I guess one other thing to note here is a lot of our examples here, we have a very short sleep time, like 5 seconds. So we get faster responses. If you are running 5-10 minutes, you do have to wait for those responses. So if it hasn't responded yet, you probably get another message like in progress or something like that. So that's getting tasks back from a command. We go to the next slide. So likely, Swagger UI is great for testing routes and more useful for developing things. But eventually, probably going to be writing, code like Python or using the OpenAPI SDK to generate your own stuff. So here's some examples of some code snippets of what that could look like getting beacons or getting LS, and then using that in your Python scripts or other languages. Go on to the next slide. So one of the things we wanted to add was like server-side storage, and that could be assemblies, BOFs, DLLs, etc. And under the REST API directory, there's a REST API directory, and underneath there's like an artifacts directory, and then you can have subdirectories. Your choice. We do have kind of an example layout of how we would do things, but you don't have to follow that. The only required directory underneath artifacts is the generated directory, which we'll see later in the demo. But for this demo here, we'll be putting something into the assemblies directory. So go ahead and play that one, I guess. So yeah, running WSL here as well. So we're copying, drilling down into the REST API assemblies artifacts directory, and we copying in our Rubius from another location. And now we'll use the artifacts endpoint here and execute that. And we can see that the Rubius artifact has now been added into the artifacts directory. And now we'll want to use that, and we'll come down here to the execute assemblies endpoint. Go ahead and try that out. As usual, we'll need to paste in our beacon ID. And then down in the request body, we will basically select all this and then paste in our command that we want to use. And that's referencing the Rubius executable, and I believe it's running the Kerberos command with an out file. Again, we'll get the response, we'll grab the task ID, and now we'll go back to the task endpoint. And get there. We'll try it out, paste in our task ID, and then we'll get the response for that. And as you can see, the response here in the Swagger UI is kind of you can see formatted text in there and stuff like that. Like if you took this and created like a simple curl to request that task ID and then dumped it to your standard out, it would be printed in a nicer format. But obviously, if you used it in some other programming language, it would dump out much nicer than here. So it would be similar to the Beacon Console output. So, and that's how you would execute something from the artifact storage. Go on to the next one, I guess. So next we have the server-side storage, where we have CNA scripts. So this would be like CNA scripts you load into your client. And so we can go and start up the demo here. So in the bottom right, what we're going to do here is we're in the REST API directory. We're going to create a scripts directory underneath there. So it's relative to our path. And we're going to go ahead and clone the trusted sec repository for the situational boss. And once we've cloned that down, we'll go back a directory and we're going to update the CNA_scripts.config file. And this is just a file, and each line is basically a path to your CNA, and it can be an absolute path or a relative path. In this case, we have it underneath the REST API, so it'll be a relative path. Paste in the location of the trusted sec CNA, and then we'll go ahead and start a REST server. And in the logging output, once it gets started here, we will see that down below that the SA CNA script has been loaded into the REST API. So that's where you can kind of validate which scripts have been loaded. And so back in the UI, we will go to the log back in and regenerate a token. Since we just restarted the team server or the REST API, we need a new token. And next we'll look at we're going to go and run the console command. So again, we'll need a beacon ID. We already had that pasted. And in this case, we're just going to run the whoami trusted sec command. We'll execute that and grab our task ID. And then we'll flip back over to the REST service API logging, and you'll notice that we did, in fact, execute the whoami object file. And so that's a way to, verify any logging you have would end up there from your CNA scripts. So go ahead and get the task endpoint, and you can see the output is the whoami from trusted sec. All right, the next demo, we're going to go on to the next. Okay, next, be generating some payloads from the team servers. So we can go ahead and start this up. So the first thing we'll do is, what are we doing here? We're going to execute the artifacts directory just to kind of show what artifacts we have currently in here. And right now we have loaded the ACE loader URL, and we're going to use that in our payload generation here. So we're down in the payload generation, and we paste in our generation request body, and is highlighted there, we are specifying the ACE loader URL, or sorry, artifact, and clicked on execute, and that responded out with the output. And now we go back up to the artifacts directory and see that the payload has now been generated there. And right underneath there, you can kind of see there's an info file, which is also just contains the response body of that request. These can be downloaded through the payload get route. So you can download both files. You just have to specify just the file name. You don't have to specify the full hierarchical key. So in this case, I think it would be, I can't read that. So whatever that file name is, and that's where it would be at. And so that's kind of showing the server side generation there. One thing with the payload generation, didn't really show it very quickly. In there, you can kind of specify the sleep mask CNA and the UDRL CNA, and you can specify them to override what you might have loaded into your CNA config scripts. So those would override anything in there. So it allows you to have, other CNA scripts that you might want to use for a particular payload generation. But you can load, like, all routes would take. So you can load your regular UDRL or sleep mask kits into the CNA config right away, and those would always be used unless you overrode it here in the payload generation. But at this time, payload generation is the only place where you can overwrite those and use something different. All the other routes will take those CNA scripts from the main storage area. If that makes sense. And I believe that is it. So back to you, Peter.
Yeah. So thanks, Chris. So indeed, if we look back at like the longer term objectives, we'll see the first hands of like server-side storage, as well as automating with curl Python, whatever you want. And that also allowed us to, like, I mean, we do quite rigorous testing. except for my slide deck. So where is it gone? Oh, there it is. So we also wanted to tinker and test what we can do with it. And for that, and so the features that were demonstrated by Chris on server-side storage, well, they're only available in the REST API. And that's where our colleague Pablo took over and said, well, now I have a REST API. I can tinker with it and I can try to push some limits. And that's what he will talk about.
Okay, so thank you. So I'm Pablo. I'm the product manager of Cobalt Strike, and for me, it's almost the first time that I felt that I could tinker with Cobalt Strike. So REST API was a great toy to play around and to do nice things. So today we have 3 demos related to that to these games that we made. One is about using the FAT client, using the server-side storage, the REST storage, and then server-side execution of scripts. The second one is a mobile web app that we vibe code just to check what we could do with the REST API and to validate that it was possible to create alternative clients within for the product. And the last one is connecting Cobalt Strike with an LLM with Claude in this case with Claude Desktop through the MCP server and the REST API. So the first one is about server-side execution. So basically, what we did here was I think it's similar to what Chris shows. So basically, we here in the server, in the REST API artifacts folder, we have some assemblies. In this case, Rubio, Seatbelt, and SharpUp. And then we created a CNA script that we load in the client that will basically connect and interact with the REST API to run these scripts, these aliases defined in the CNA scripts that are stored server side. So here they are. So here's my examples. I have the server side artifact execution. So once it's loaded, so we can go to a beacon, and here we'll run help, and in the help we'll see this new command, which is execute server side assembly that basically will execute Rubius, the Rubius that we have stored server side with the CNA that we have server side. So here we have the available options in the artifacts folder. And then we launch the same command that we show before in the other demo. So basically, it's rubius.exe with the Kerberos command and the out file to store the files in the downloads in the victim machine. So there we execute it, and here we can see that this user, the CS REST API user, ran the script that is stored server side, and we got that nice output. So that's a way to have all your scripts in the server. So every red team member would be able to use the same scripts, and that way we make sure that not every operator is using different versions of the same script. The second demo that we have for today is a web client that we did. So we did it using Copilot really fast, but it shows what the API enables for our users. So basically, you have the login interface. You can list the beacons with all the information that we have, and then we can open the console command. So it could happen that you're in the train, you don't have access to your laptop with Cobalt Strike, and you can open your new web UI from here, and you can upsleep the beacons. You can run a PS. You can check if any new beacon checked in, and you can do all that from the web UI using leveraging the power provided by the REST API. So here's some examples. We run PS, we run LS now. So we and finally we run who am I, which we have the result here and the ipconfig, and those are commands that are coming from the trusted sec situational awareness buffs. So basically you can run any command that you have available in the server side. You can or any script that you have available server side, you can run it also from here through the web client. And the last demo that we have for today is basically about MCP and LLM and connecting Cobalt Strike to Claude in this case. So here, basically, our prompt, what it does is to imagine or to make Claude think that it's a red team operator doing an internal engagement. We have some machines, some workstations that are compromised, and we're trying to harvest some credentials. So we're asking it to look for clear text passwords, and then we give it some hints, like when possible, use native commands instead of launching the operating system shell, and we ask it to use the MCP servers that it has available, for not allowing it to go crazy and try to do crazy stuff without connecting anywhere. So basically, we wrote that prompt, and then this thing it starts thinking. So it checks the ethical if there's any ethical concern to do anything. So it didn't find any. So it automatically enumerated all the active beacons. So it gave us information about the user context of each one of them. Then it automatically launched the process listing, and it did this analysis of the processes. So it got the critical processes, the beacon processes, where there's a logged in user detected. It detected also some security software that was installed there, and then it starts the credential hunting process. So basically, it checks what it's located, what its working directory. It will execute. It will navigate through multiple directories, looking for useful information. It found in one of the folders this hashes.txt file. It checked that there was a Bloodhound export, some other beacons. So it even thought at some point that it could be the machine of a blue teamer having that. So when it finds all that, it downloads all those interesting files automatically into the team server, and then it will read them. So it will get the information from those files to look for specific credentials that it can find here, and it adds those credentials to the credential store in Cobalt Strike. So basically, with just a prompt and giving the LLM connectivity into the ability to work with the REST API and with Cobalt Strike through this MCP server. So we have like one more team member that could help us to go through the engagement. And finally, the last thing that this prompt does is to generate a report of everything that was done. So it tells you all the information that it could find about each one of the machines. Here we find the critical credentials that it found and where it found them. It offers some recommendations, some tactical recommendations on what you need to do. So like using the master password to get to open the my passwords, the KeePass database, to test the domain credentials and validate if there's any lateral movement opportunities. It tells you what were the artifacts collected, and finally it provides the next steps that you can use to go further in your analysis. So that's basically what we have. All the three of them are prototypes that we used, that we created internally to test the REST APIs. So probably we will refine some of them and release them as open source for you to tinker with it, so you can play with the products yourself and extend them and basically show us what you're capable to do. So sometimes you build things that we never thought on. So those are just some examples, but now the ground is yours, and you can play with it as much as we did, and we hope that you enjoy this new feature as using it as much as we enjoyed building it. And back to you, Peter.
So what Pablo hasn't said is that the 3 examples that he gave, we will be polishing them up and then open sourcing them. For us, the first priority is getting the release out, and then maybe 1 week later, you'll see dripping them through in our GitHub as well as on our blog. We may summarize a bit about what we did there. So Cobalt Strike, what else? We already packed a lot. We're getting to the end of the hour, so let's quickly run through some of the other things that we're doing in this release. Pablo, next slide. So besides these main features that we highlighted, the pivot beacons will use a novel sleep mask. So in 4.11, we introduced a new sleep mask for DNS and HTTP. We're now also using that for SMB and TCP, the pivot ones. Drip loading, so instead of loading and one big chunk of memory, doing very small parts to hopefully evade an EDR, a feature we're introducing in the reflective loader as well as in the process inject. We fixed some bugs where the SSH beacon crypto was not able to connect to newer Linux or Mac distros, which is also great. We hammered that one out. Some customers run IPv6, then you may be struggling with socks. No longer anymore. For now, we'll have full IPv6 support. If you write a BOF, there were restrictions on how many dynamic function calls you could use. We now have that one set to unlimited, and we're introducing a new beacon downloads API call in beacon.h, where a BOF can offload downloading a file towards Beacon. Besides that, some other minor, smaller bugs, changing as we did the task management, also fixing the logging, a lot of other stuff. Read the release blog somewhere next week over Thanksgiving. And with that being said, let's move on to the next slide, Pablo. So as a recap, we as part of the R&D team are very proud to be part of Cobalt Strike, this battle tested and stable command and control product. We bring you evasion built in, but also offering you lots of options. We want to be this extendable and this framework for future offensive research. And with the step we're making today or next week, we really believe that we're doing the right things. We're introducing user-defined communications, allowing you to make to write simpler channels for egress. The process inject and UAC bypasses help all of the operators out there. REST API, we hope that this will also spin in new offensive research with bringing LLMs into the world of Cobalt Strike. And as mentioned, the prototypes for the MCP server and the web app, etc., they will follow after the release. Many, many more. I really hope that we squished the last bugs today, or some of our colleagues who are working right now are squishing them. There's some final testing going on, and then we really hope to release early next week. With that being said, I want to thank all of you for the attention. What we will do is we will turn off the microphone and the camera in a couple of minutes. If you have further questions, here are some contact details. Then we'll stay around for maybe a couple of minutes to see if there are any pending questions that are in the chat. And from there on, we'll just sign up on this meeting. So again, thanks for this one. Thanks for all the questions that have been answered in parallel to this. We are also very much eagerly waiting for your feedback on this release. So in the next release blog, we'll also introduce a feedback form. So give us your feedback. What are you thinking about this new REST beta? What do you think about UDC2? Tell us and help us make our life better tomorrow from every day onwards. So again, thank you. We're now signing out, and we'll be answering questions in the chat. Bye-bye.